Hello, my name is David Reyes from the University of Bristol. I'm going to tell you about my novel over-the-air test method for 5G millimeter wave frequency devices, which is capable of emulating three-dimensional real-life scenarios to test the performance of the devices in a cost-effective way. 5G new radio specification adds new operating bands in both sub-6 GHz and millimeter wave frequencies. This additional spectrum will increase the capacity of the networks to handle the constant increase in demand of mobile data traffic and the number of interconnected devices. However, they also expose signal propagation issues, such as increased path loss and higher susceptibility to blockages, making it more difficult to establish and maintain a wireless link between the user and the base station. To overcome these propagation issues, both ends of the link will employ phased array antennas, which enable beam steering techniques that can direct the beams in specific directions. These arrays are compact devices, highly integrated with the transceiver electronics, which have no place for connectors. Therefore, it is essential to test the performance of the devices, including the impact of the antennas and the beam management functionalities. And this can only be done over the air. Current over-the-air methods for testing legacy devices cannot be directly used, either because they are not technically capable or would be very expensive to implement. To test 5G devices, it is required to emulate a real-life millimeter wave propagation channel, which is composed of 1 to 4 narrow beamwidth signals with different power levels, illuminating the device with multiple angles of arrival. Therefore, I have designed, built, and tested an elliptical cylinder reflector that, due to the reflective properties of the ellipse, allows to emulate the right environments for testing 5G millimeter wave frequency devices. The reflective property of the ellipse states that any signal being transmitted from one focal point will arrive to the other focal point, and depending on the angle of departure, each signal will have a different angle of arrival. With this test setup, it will be possible to test the modulation, radio resource management functionalities, and beam management algorithms of the device, while they perform as if they were in real-life environments. This method could be used by commercial and academic laboratories engaged with millimeter wave frequencies, test houses providing wireless device performance certifications, test equipment manufacturers, and handset manufacturers. To summarize, an innovative approach that overcomes the limitations of current over-the-air test methods was presented, showing that with the help of an elliptical reflector, spatially dynamic environments can be emulated to test 5G millimeter wave frequency devices. Further tests are being performed to fully determine the validity of the solution. Thank you for watching.